Yeah.
All right, good morning. Can you hear me in the back row? Hello to the back row. All right, apologies, the networking failed there on the port that we normally use for streaming to YouTube. So a huge thanks to Tom and Ben who, fingers crossed, have some sort of, cobbled together some sort of set up that has us streaming out to YouTube successfully, and I shouldn't walk away from the camera with the microphone. All right, hello to everyone on the stream. Apologies for the lower quality than usual today. It all should be fixed next week. All right, for those that haven't been paying attention, Sasha is in the United States. That's the bad news. The good news is you get her back Monday. In other news, assignment 1 out real soon now.
5 minutes or so.
Sorry, assignment 2. Assignment 1 was due Monday. If you haven't submitted something for assignment 1, the UNSW standard late penalty applies. So you can still submit something up until, I think, noon tomorrow? Was it noon Saturday?
I think it's Saturday. I think it's
So
8 p.m. Saturday.
submit something, please. It makes lecturers cry when we see students who think, oh, I didn't do a great assignment, it's not worth much, I won't submit it. And then submit whatever you've got. All right, if you haven't. All right, I've got to recap Malak and Pre really quickly. Then we've got to talk the most exciting topic in COMP1511. That's the good news. It's really interesting and clever. The bad news is it does take a while to get your head around. So Sasha will be revisiting this at length in the next 2 lectures, I would think. So I've declared my array backwards. You'll have to forgive me. This is a new low for me. I'm actually using Windows laptop to get on Ben's laptop to give a lecture. It's never actually come to that for me for a lecture in the past. All right. So I want to talk about storing things in programs, in running programs, I popped up a stupid example, which is storing information about a student, the sort of stuff. So I set up a struct there and said we stored the ZID, the number of courses that are enrolled this term, and the course codes. All right. Doesn't look like a particularly smart structure to me. What would worry you about that structure? There are two things that worry me about that struct definition. All right, no one's helping me out here, but wait, I have an inducement. Somewhere in here. Mars bars, I think. Did I pack them? All right, to get things going, two things wrong with my struct definition. Yep.
It only allows for 3 courses.
So it only allows for 3 courses. Can you take more than 3 courses that you want to study in a term? Yes, you can. So you can have chocolate for that. Yep.
What if number of enrollments array of one?
Sorry?
The number of enrollments variables would just be the size of one of the, like the amount of columns in the array.
Can it though? I don't think it can. Well,
The
ooh.
rows of non-zero
Oh,
values
yeah,
in the
that,
array.
so that's, you sort of can, but this is actually one of the problems with C. This stuff gets very awkward. You actually can, but this is a special case. I'm not going to give chocolate for that, but it's a good thought. Try again. One last thing. Yep.
Uninitialized values for ZID.
Oh, I haven't initialized anything there yet. It's true, but not worth chocolates. The 3 and the 9. Does something worry you about the 3 and the 9? White shirt? Yep.
No, actually, I don't know. I had an idea.
Yep.
They're just arbitrary values.
And
Should they be defined, I think.
they should be hash defined. Yes, we don't like magic numbers. We don't like magic numbers in the code. All right, let me code on quickly. Oop. All right, consider my code. Consider my code. What does it print? This number, this strange number. 7FFF787DA9520. What is it? Yes, someone here.
It's the memory address for the
It's a memory address? True. Oh, it's the memory address of what?
variable Andrew.
It's the variable Andrew's memory address. Where does the variable Andrew live? What part of RAM? The stack. The variables of a function, the local variables for a function are placed in a part of memory we call the stack. Don't freak out about that. That's a COMP1511 topic.
Yep, that's right.
Sorry, I'm not used to this editor and it's causing me my pre-programmed brain. It's leading me astray. What does this program print? All right, I'm getting a lot of love for an error. We'll see if it actually does. Actually, it'll be interesting. Does DCC on this machine do that? Oh, no. Oh. So we're using Ben's laptop and it doesn't have all the checking of DCC functional. If we ran this on a VLAN or a CSC server, it would.
This is a station CSC.
Sorry?
This is, yes.
I'm disappointed. DCC is meant to pick that up. All right. We're getting so this is the normal experience with C programs that don't have DCC checking for errors. We're getting an initialized value. Here. But why? S pointer points at this variable Andrew, and Andrew's never been initialized. Right, there's the program working. Line 19. Can you tell me anything about line 19? Nothing you can tell me about line 19. Hint. Lecturers like to think at their last lecture, people learn something. There's really no point in giving lectures without learning. Yep?
You could write that bracket bit with the pointer differently by removing the brackets and the dereferencing star and using a star.
All right, you've got to lie to me and tell me you learnt that because of my brilliant lecturing.
Yes.
I did.
My life has meaning. All right, there is a nicer shorthand, a much more readable shorthand for saying I have a pointer to a struct and I want to talk about one of the fields. There's a problem here with, well, imagine we've got to store data about UNSW students. How many students are there this term at UNSW? 50,000? I think it's a pretty good guess. It's something like that. So can you imagine declaring a program with a function with variable for him, for him, for him, for him, and so on? It'd get a bit tedious, wouldn't it? This keeping data in individual name variables, sure, it's good for some purposes, not so good for others. Because, well, there's two things. It's how many of them we need, and the other thing is lifetime. So it's actually okay here. We're also okay here in main, because main is called when the program starts, and it's all over when main returns. So those variables live for the entire lifetime of the program. But in the other function, its variables are destroyed when the function returns. That's a problem with trying to put stuff inside other functions. We have a solution. The solution is malloc. So we'll dump that way, And we'll have to change that down here somehow. I know how to change. Well, actually, I'll ask you how to change it. Malik, you say, I just want a chunk of memory. So I've said, look, give me 1,000,000 bytes there. Now that's bad. That's really bad. Don't do that in your program. Don't be like Andrew. And whenever I like, I can say, I'm done with that memory. I can do it one line later. I can do it in a long-running program. I can do it 5 days later or 5 years later. It's completely up to me. So I've got a piece of memory for storing stuff whose lifetime I control. Is 1,000,000 bytes enough to hold that struct? Yes, it is. Too much, way too much probably. What do I want to put in front of ZID there? S pointer arrow, I think, is what I want to put. Some people call it dagger, which seems a bit violent to me. I like arrow. Actually, is there arrow any less violent than dagger? It's a good question.
Something.
Right. That all works. So we allocated a piece of memory. You say, what's the big deal? We're getting to some of the clever things you can do because you can allocate pieces of memory. But let me note, I can stick this in a loop and allocate 1,000 pieces of memory. And you're also good at loops by now. So imagine we've got to allocate information with every UNSW student inside a loop that executes 50,000 times. How easy is that? All right. I said don't do that. That's allocating far too much memory for that struct. Tom, caught you on your phone, didn't I? I guess that's good. All right. How many bytes do I need for that struct, do you reckon? You've done COMP1511. So Tom's working it out, and he'll probably get it right. But the truth is, it depends. Oh my God.
What does it depend on?
It does actually depend. No, it's not 9. Oh. Uh-oh.
Yeah.
All right. So we've found the solution of the problem here. So the C has a built-in way to find out the size of a struct. Come and do COMP1521 and find out why it's 36. As I said, I'm not telling you until you do COMP1521 with me. You've got to pay the extra hex to get the answer to that question. Or you could look it up online for free, I guess, but chat GPT, yeah. All right, so I can do that. That's stupid, isn't it? Every malloc should use a size of. So what I should do if I'm is that. Now that might look a bit clunky and lame, and it is. C is a very old language and it's showing here. So come and do COMP1511 and you can see what a really modern language does for this. Some of the other courses will expose you to other languages, but 6991 and Rust would be really to see this sort of thing done right 50 years later. Oh. What do we notice about that number? When the pointer was pointing at a local variable, what did the number look like? All right, there you go.
Thank you.
So malloc gives us chunks of memory from an area that's called the heap. For no particularly good reason, but it is. And you can see it in the number here being quite different. All right, you'll have to bear with me for a second. So, C arrays get, fixed size arrays in any language get really annoying. You don't know what size to make them. I know someone who's taking 4 courses, but is there someone that could be taking 5 courses? Is there half-unit courses, 6 courses? What's the maximum? Similarly, how many students? There's 50,000 this term, and is there 55,000 next term? Will there be 100,000 next year? Consider the struct on the screen. A struct. It's got 2 fields, but what do you notice about the second field? It's a pointer, and it's a pointer to the same type of struct. So we can have one of these structs with a pointer. I guess we could make it point at itself, but that would be pretty useless. But it can point to another struct. So we can say, go from this struct to another struct. So I can have a struct for him as a USW student with a pointer to her, then a pointer to him, and a pointer to him, to him, and him. I could link together with pointers every student in this lecture theatre. All right, so I've set up two structs for each for a different student. Can you have consecutive ZIDs? Can any number be a ZID?
No. I feel like 8 digits.
Can any 8-digit number be a ZID?
Yes.
Are there ZIDs that don't start with 5? Yes, there are all ones. Let me ask a different question. Someone have a credit card here? Yeah. All right. So, can any number be? There's an obscure part of your number. Can any number be? Cybersecurity student right there. Can any number be a valid credit card number? No. So there is some check built into a credit card. We used to make it a student exercise, but do boring calculation. Just a side note for you. You can research that later. Let me try some. This was something I wanted to try here. What have I done wrong, and why haven't you helped me out here? Come on, I'm compiling this like an idiot, and you've all spotted the problem. What's the problem? Aren't they the same thing? No, they have to match. Ooh.
What? Make like every function like.
So close, so close. All right. I want two ways to change line 20 so it prints out the ZID of the second student. I want two ways to change line 20 so it prints 5, 1, 2, 3, 4, 5, 6, 8. One way.
Can you say student pointer 1, arrow next, arrow?
Oh, that's the best way. All right. Save that. Well, here, have your chocolate. But what's an easier way than the? Yep. So that's the no chocolate way. No, that's not fair. All right, there's your chocolate. Oh, nice catch. All right. So that's, if we've still got that pointer, that's fine. Look at that. Oh my God.
Would you have to really explain the view and
Okay. Hopefully you didn't hear what he said. The answer to your question was about to ask. In the middle of the theatre, tell me something wrong with that program. The compiler won't pick it up, and it will run with normal checking and there'll be no error. But there's an error in that program. For every malloc, what should there be? How many times is malloc called? How many times is free called? So there's a memory leak in that program. Um,
can you define several language instructions? Like, can you, instead of saying s point to one, stab CID is equal to whatever, and then stab next is
I think the next lecture is going to answer your question. If I've got that right, if I've connected everything together properly, that's chained together 3 students. So there's a pointer from one student to the next student, from that student to the last student. Line 25, what does it print? He's saying no, yeah? All right, so for the print on line 25, there's some confusion. Look at it and think. So the person was saying the next field is uninitialized, they were right. But I have an existential problem here. What do I make it point at? I've got 3 students. I can point from him to her to him. But if there's only 3 students, who does he last? So there was a suggestion we use something like that. You don't hear, you don't. Except it's an analogy. What's EOF? It's a really special value returned by getChar to say there's no more input coming. So we need a special value for pointers. And a lot of people remember that special value is null. So it gives us something we can initialize the pointer to, a definite value that says this pointer goes nowhere. So that's now a valid program which prints out and it happens that this printer prints out brackets nil for null pointers. Yeah. Tell me something about lines 15 to 19, no, 15 to 20. Tell me something about lines 15 to 20. Right? There's a good suggestion here. Well, what's worrying you about lines 15 to 20? It's repetitive. It's repeated. One thing we can do with repeated code is put in. All right. Is that a valid function? Line 36 and 37 maybe tell us something we didn't know. I used the same name for a variable that's also the field of a struct. And you can do that apparently. Is it a good idea?
Yeah.
It's getting a vote from the second row. Here's a tip for how to not to make lecturers sad, is use the back exit so they don't know that you're dropping out of your lecture. Oh my God. So many things going on with my program, I need help. My program.
Hey, everyone, let's try and get the blame down a bit, please. Thank you.
All right, I think my only problem for all that mess of errors, the absence of a prototype. That's what it was all about. Why does C1 prototype? Yeah, and then why does C1 prototype? Before you call it, superb answer. What's your question? Yeah. I am returning something. I'm returning a pointer to the thing I created. I'm putting that pointer in the struct. Yeah, it's really good, isn't it? I'm creating a new struct. I'm passing it a pointer. I'm putting it inside that struct. So, it's a good question. And a good answer is why we have prototypes. And that all works. What's wrong with that program? What's wrong with that program? Yeah? Some of it could go in the loop, that's true. We'll get to that in the second part of the lecture. How many mallocs have in that program? Yeah, that's a bit tricky, isn't it? How many mallocs? There's only one called a malloc, but it's inside a function. How many times is the function called? 3, so 3 mallocs. So how many frees are occurring? 1. So we have a memory leak. But you could write a function, by the way, yes, but just for this, I've got the plan. I don't have a variable pointing at the second struct, but I can use the next pointer of the first struct. Is it really? Oh. Okay. All right, this is important. See if I can get your attention to explain this. My problem here is a thing that torments programmers when they use these sort of linked data structures, and programmers do endless stuff with linked data structures. The problem here is, I've said on line 20, look, I'm done with the struct that S pointer points to. But what do I do on line 21? I say, go to the struct that S pointer points to and get its next field for me. What it does is terrifying, because in a real world system, that memory may have been given to some other part of the system. So you may be accessing memory that's being used for something else. And this creates nightmare bugs that behave really erratically, occur once every 2 weeks at midnight or whatever. Or worse, malicious people figure out that your system has this flaw and in incredibly complex ways exploit it. Do you want to know how complex the ways are? Google Project Zero. It's Project Zero at Google, and read some of the blog entries there, and you'll quickly discover there's just mind-overwhelming complexity involved in some of these exploits. But a lot of them start with something like line 21. All right, how do I fix that? Reverse the order. Yes. Can I do that? Does that have the problem before? Oh, that's great, isn't it? I'm running out of Mars bars, but here, have one of my last Mars bars. All right. So my friend here has been saying, Andrew, you should be using loops. I want to use loops. And we'll get to that in the second part of the lecture. Yep.
Why do you start by defining the null one and then you
Oh. So the question is, why are lines 15, 16 and 17 in that order? Can I rearrange them? I'll leave you to think about that during the break. Oh, actually, I've got to flip. We're going to take a quick break, like 2 minutes, 3 minutes. But I'm going to Alt-Tab to... You can think... No, yeah, I'm not answering the question. You can think about it. I've got to figure out how to Alt-Tab... Sorry? Oh, I don't know what I've done now. I've broken it. Ben's going to fix that. Do we want to put it to the... Actually, no, leave it on that. We'll let people think about that. We'll save the... To reduce the chance of errors clobbering each other. But in a real malloc, they'll be 8 bytes apart.
Yeah.
8, 12. It's harder with if you go to things like real, But there's clever Let's see how we go then.
I'll give you a thumbs up to make sure.
Are we good? Testing, 1, 2, testing, testing. Okay, if you could take your seats, please sit down. All right, and those people eating in the lecture theatre, make it look like I don't know, please. All right. Yes, I think there's a very good reason to ingest sugar halfway through a lecture. Ahem. If we could sit down or leave. Thank you. Don't make the lecturer grumpy. All right. On screen are some linked list facts. So a linked list is what we call these data structures where we get structs that can contain pointers to another struct of the same type, and we chain them together. I chained 3 together, but there's no reason you couldn't use the same technique and chain 3,000 together. Now, it'd be a bit tedious to do it with individual lines of code, but my friend here was saying, Andrew, why aren't you using a loop? And indeed, you'd flip to using a loop. So these data structures have advantages and disadvantages. They do take extra storage because we've got to store the pointers. You don't have that with an array, you just store the data you want to store. So there's an overhead, but there are advantages. It's hard to take out the element in the middle of an array or insert an element in the middle of an array. It's easier in some sense with these data structures because we can just rearrange pointers. So we could take one element out of the sequence and make the pointer go to the one after it. Oh, what an idea. All right. Arrays do have a nice advantage. They're what we call random access. If I've got an array of 50 things, none of them are really special in any way. I can get to the last one, the 50th, just as easily as I can get to the first one. I just supply an index, I get the element. Supply an index assigned to the element. These linked lists are not so easy. If I chained all the students in this theatre in a linked list, getting to the first one, this guy here, easy. Getting to her, second in the list, okay. Him, third, pointer, pointer, pointer. Getting to the last guy right up in the back, I have to go through 50 or 60 pointers. So there is a cost. Now, it's just a couple of lines of code if I write a loop, but it's a cost. So there are different data structure. You're saying, is this it? Is this just why we're learning about linked lists? No, no. Linked lists are the first of a set of linked data structures. If you're in a computing degree, you have to take COMP1511. I've said it's actually the crucial course to think about where it's in your program because it's a prerequisite for so many things. And it covers other more complicated linked data structures. This is just your first taste of using pointers to chain together structs or objects in a data structure. Yep?
So you mentioned that cost, right? So how much, so even though it's only a couple of lines of code, how much will it actually affect your performance if you have a very large list?
The answer to that one is a big it depends. But there's actually a whole pile of maths that's been around forever, which is really important in computing, and one of the most interesting, exciting parts of computing. They'll touch on it in COMP1521, but sorry, you won't get it all there. Do algorithms or extended algorithms, and there's a whole world there about the costs associated with accessing things in data structures. Now she's worried because she's got 10,000 friends on Facebook. How are they in a linked list? Is there an efficient way to, if I get 100,000 friends, you get 1 million followers on Instagram, what are you going to do? Are there data structures for that sort of stuff? And the answer is there are, but they're more complicated. Of course, if you're like me, and I think I've got 9 friends on Facebook, it really doesn't matter what data structure is involved. Linked lists are everywhere. In this laptop, there'd be linked lists used in tens or hundreds of thousands of places. In fact, inside the cables and everything here, there's linked lists just hidden out of sight, just everywhere. All right. Now, next week's student, someone asked, why struct node? And the node is just a name. It's copied from mathematicians who've long used it when they've talked about graphs and things like this. But it's what we'll try to. I used it because it's going to be the same as the lecture slides, same as next week's student lab. So we'll use it for a few things. But if you did a different computing course, they might use a slightly different name there. And we use pretty simple nodes for a lot of this stuff because we're interested in the algorithms. He's interested in how to write loops. It doesn't really matter what data. So if we're storing data about a student, I mean, UNSW probably has 50, 100 pieces of data stored about your phone number, home address, so on. But it doesn't make any difference to the algorithms, the loops, the way we do things. So we're just assuming, we're storing a ZID. Storing anything else doesn't change our code much. So my math lecturers used to love saying, without loss of generality, so I'll say it here, without loss of generality, just assume all we've got to store is an int in our linked list. I don't think in the assignment you'll put more than an int in the linked data structures. It is true. And that's a lovely. Sasha does beautiful. I feel very bad for my students because Sasha does such great diagrams compared to what I do in my courses. So there's this weird thing. So we've got a pointer here. We can get its next field and go to the next structure, get its next field, and keep on going. So if we just need one pointer. If I change you all together with pointers, as long as I've got a pointer to this guy, I'm right. I can get to everyone in the theatre just by pointer, 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 all the way. I'll get there eventually. I think that makes me think I want to do some coding. Yeah, I do. I want to write a loop. This guy's been bugging me for the last 20 minutes. Loops. Well, he should be as well. I mean, what's been the whole message of the first couple of weeks? Loops are great. We can do so much with loops. Why we learn about loops? There's a question about why am I lecturing on Windows. There we go. All right. All right. No. Line 27, I want to create a function. I've used the type void for the function. What does that mean? Sorry? So void means, I think you said nothing. It doesn't return anything. What's the point of a function that doesn't return anything?
It can still modify information.
It can still modify what? Oh, it's true. It could modify pointers. That's true. This function isn't going to modify any pointers. Is there still any point in having a void function that doesn't take a pointer and modify it? It can change the world. Not necessarily in a good way, I should say. So that's one way. The computing term for that is often side effect. the function has a side effect. So we talk about functions' main job is to give you back a value. And true, if you're a mathematician, you go to the maths faculty and they say, that's just what a function is. And they're talking about sine, cos, and so on. All they do is give you back a value. In computing, we have a different notion of a function, which functions can have side effects. It does make them more complicated things. The side effect could be send some bytes on a network, it could be create a file, could be set fire to the computer. In this case, it's print out some stuff. When we work with these weird chains of linked together structs containing information about UNSW students or whatever, we often call the pointer to the first struct in the list, that crucial pointer pointing to him, that will get us to every struct in the list. We often call it the head. It's not the only word that gets used, but I think it's the COMP1511 favoured word. So I want a function. Give me a pointer to the first thing in the list. It prints them all. If this was an array, hopefully you'd be laughing at this point. You'd be saying, Andrew, I know. Initialize I to 0, while I is less than array length, print out array I. I know how to do that. I hope you know how to do that. I'm sure you do. All right. There is an analogy with a list. A lot of people would call this a programming pattern. A way of having a loop. So I've just described how you have a loop that executes once for each array element, to let you do something for each array element, print it, change it, zero it. There is a way to have a loop that executes once for every struct in these linked list of structs. Think about what you want to put on lines 30 and 31 while I change the code up here. Oh, don't know what I'm doing. All right. Suggestions for line 29 first. If P points to a thing in the list, suppose I'm P and I'm pointing at him, how do I make P point at him? So the suggestion is, someone's put it in using the horrible violet language of P stab next, which a lot of people do use. I don't like it, it is. But the suggestion, this was the suggestion here. All right, I'm running out of Mars bars, but there you go for that suggestion. So yeah, and that should make sort of logical sense. We're moving down the list. If P is pointing at one of them, if I say make P, assign P next, it'll be pointing at the next. So we've got a loop that will move steadily through the elements of the list with P pointing them in turn. Line 26 starts as with P pointing at the first thing in the list. How do we stop? So I've heard, I'm not handing out chocolate because I've heard a few people shouting the answer, but yes? P not equal to null. All right, have we got it right? Will this print out the 3 ZIDs? All right, my friend there, a couple of rows back, there is your loop, lines 27 to 30. We finally have a loop, and it is a big thing. It's our first loop with these linked data structures. You're saying, Andrew, I want to write more of these loops. You probably aren't, but whether you are saying it or not, hello camera, whether you're saying it or not, your future in the next couple of weeks is lots and lots of loops, assignment 2, lots and lots of loops involving working over these linked structures. That's the simplest of the loops. That's the classic one. So please don't think, oh, that's weird and complicated and that's a side note like realloc last week or Andrew said. You can understand that later if you need. This, you have to understand, sadly, this is sort of crucial to getting through the next couple of weeks and doing the assignment. This approach we've just got there in print nodes. All right. Are there any questions in the chat that I need? No? Right, we're good from the chat. Notice print nodes. Notice print nodes. It doesn't just work for a list of 3. It works for a list of 3, 10, 3 million, 2, 1. Does it work for a list of 0? What is a list of 0? It does work for a list of 0 because it's sort of a null pointer. You can have sort of weird problems with 0-length lists, representing them like this, but not in our case. All right, different topic. Well, highly related but different topic. Lines 16, 17 and 18. I think my friend in black here asked the question, Andrew, why do you create the last node in the list first? Because if you think about how it all changed together, imagine all these students in the lecture theatre are chained together except this guy. It's really easy to put him on the front of the list because I just make his next field point to the current student on the front of the list and say, now he's the first student in the list. So it's always easy to put a node on the, it's easy to put a node on the front of a list. Yep?
Does that make adding to a linked list a bit similar to adding to a stack?
Yes. So a classic way to implement a stack would be a linked list. You're saying, can a C compiler use a linked list to implement functions? Yes, it could. It would be a little bit slower, but there are C compilers that have done that. It'd be a weird way to do it, but it'd be fun. So the front of a linked list is easier to get access to than the back. Now, that's not always what we want. You're saying, look, I don't want to put him on the front of the list. I want him way back after the guy in blue in the back row. And that's sort of hard. If you know how many things in the list, you can sort of fudge it, but it's hard. So can I write a function what I want to do I want that function. So I want a function that creates a new node with a ZID and connects it at the end of the list. Yep?
So we're trying to append to the end of the list.
Append is another word you could use here.
Have a pointer temp with the node, and then keep going till temp.next is null, and then say temp.next equals whatever you want.
All right, you've got way ahead of me here.
No, it used to be but it's got really bad indexing functions on access, so you can't find the last value. Or like something separate. They basically and everything, and then it's actually that's what it's wrong. And it is valid. It's a 2521.
I just had a great idea. I can use create node from this function to do the work of creating the node. What's the next field? If I'm putting a node on the end of the list, what's its next field going to be? It's going right on the last, if it's a node's the last thing on the list, what's its next field? It doesn't point to anything, so it's null. So I'm creating a new node to put on the end of the list. So there's my genius level idea to append a node on the end of the list. I've copied my code. I copied the code that I used to print the elements of a list and use that to go down the list. All right. Now, I think he's got the answer, but I'm not going to ask him to tell me. I want you all to look at line 32. Let's pretend all of this code came out of ChatGPT. You know, it's your internship. You've got an internship in this upcoming summer or maybe in the summer after that. The boss has said, you know, give me code for this. You've put the boss's email into ChatGPT. ChatGPT's given you this, but now you need to check, you know, was ChatGPT hallucinating or not? Is it valid or not? Now, I'm not taking questions at this point in time because I want everyone, including those in the chat, to think about line 32. So ChatGPT has given you that loop and line 32. Can you reason about that? Let me ask you a different question. What do we know about while loops? If we're reasoning, thinking about while loops, what do we know about a while loop? Let me suppose we have a while loop that's while I is less than 10. What do we know immediately after the while loop? All right, so we've got a half right answer and a right answer there. What we know after a while loop is the condition must be false. If the condition's not false, the while loop should keep executing. All right, there are exceptions. Those tutors are just glaring at me with exceptions. But no, it's a fundamental thing. The exceptions, there are definitely exceptions. That would, but it's a fundamental thing. A while loop executes until its condition is false. So if the condition is I less than 10, I less than 10 must be false. So I must be greater than or equal to 10. Now you can combine that with mathematical induction if the loop is counting up and show that I is 10, if it's counting up. The loop could be doing anything, of course. But we know immediately after a while loop, with some exceptions that don't apply in 1511 really, that the condition is false. What's the condition on that loop? P is not null. So what do we know at line 32? This is important, not just for those of you who are thinking, oh my God, your assignment, ChatGPT, I'm so there, which we forbid. Yes, we definitely forbid. Seriously, you're not going to learn anything, and you probably won't get a good mark either. But and it's possible we'll notice that you use ChatGPT, and then we get it. That wouldn't be good. All right. This is a fundamental sort of. This is perhaps the most crucial sort of thing with programming and loops. The logic there. So if the condition on line 28 is P not equal to null, we know on line 32 P is null, which is a problem, isn't it? Yes. Because, all right, let me give you a couple of life tips. Now, there are general life tips, which one of them when I was a student was don't go out with anyone who's got more problems than you have, which always struck me as sort of numerically an issue. If I've got 17 problems, how do I find someone with 17 problems? Because they won't go out with me if I've... Yeah, see. All right, so it's not a very workable life tip. Let's give you a more specific COMP1511 directed life tip. If I'm using square brackets on an array, every time I do that, I should be asking myself, how do I know the index is valid? How do I know the index is 0 to n minus 1 if the array is of size n? Every time you use square brackets, you should be doing that and thinking that. How do I know that? If you don't know it, if you can't establish that to yourself, you should be changing your code somehow. How depends on the context, but every time you use an array index, you should be asking, how do I know it's valid? What about another life tip? Oh, every time I use a variable, I should ask myself, how do I know the variable has been initialized? How do I know there's been a value assigned? Second life tip. The third one is specific to this lecture. Every time you use a pointer, with an arrow or an asterisk, every time you dereference a pointer, every time you say in C, I want to fetch the value of the pointer, you should be asking yourself, how do I know not only has the pointer been initialized, but how do I know it's not null? Because it's an error to say, to attempt to dereference a null pointer. Null is the special value to say this pointer points nowhere. So saying P arrow next and P is null is an error. It's actually I'd call that a good error because it's caught by almost any C implementation. I was desperately disappointed in DCC not picking up an error before. DCC is designed just to do everything it can to catch any mistake a 1551 student might make. A lot of C programming is done with C implementations that don't catch these, but null pointer dereferencing is such that they structure whole operating systems to avoid issues with it. Windows will be specially configured so that dereferencing a null pointer causes your program to stop. So let me demonstrate that. I'll compile it after all. I better do this after me talking like that all that time. Let's see. It should break. What? Oh, I haven't called the function though. All right, let me. Oh.
Aren't you meant to return something? Because your function is expected to return a struct load pointer.
So he's asking a good question there. I'm asking a different question. Why aren't you all asking the same question? Why can't you all be more like him? You all should, yes, you should be looking guilty. There's a function there that says it returns a value. How many return statements in there? 0. You're a disappointment to me. You're all disappointments. All right, that's perhaps a little harsh given we've only been C programming for a few weeks. So a function, unless it's void, has to return a value, and I haven't returned a value there. But again, this is something you should be looking to. Yes, I know I mean you. I'm picking on you. You should be looking. So if you're a more experienced coder, if you're like the tutor sitting here, you're used to this sort of stuff. That's one thing you should look to. Function. Oh, where it's returning stuff. Are all paths through the function returning stuff? Yeah, that's what it does. It's sort of something you'd look to. Oh, what do I return though? Oh, maybe I don't need to return something. All right, I'm going to assume I don't need to return something. It's actually not quite true. But we can fix it later. So we'll say this function doesn't return something. Sorry. Yeah. You should show some compassion here. I've been using editors the same way for many, many years. I was writing C programs well before all of you guys were born, so a lot of stuff is hardwired in my brain, unfortunately. Oh, God. Oh. All right. We've got a problem. We're on a VLab machine, and the C compiler says user includes.io.h has got errors in it, which is the standard include file used by anyone compiling C on that server. So should I be on the phone to our system support people saying, fix this file urgently? Is there actually a problem with the file user includes.io.h as those error messages seem to indicate? No. What is my bug? Line 25 has a classic one that will produce weird and complex messages. You want to get weird errors out of a C program, you forget a brace. All right, I think that compiles. I'm not actually calling my function yet. Okay, good. All right. No. So add node to end of list. All right. Should be good. Should be good. Oh, except we've got the bug we talked about. All right, so I'm just demonstrating the bug we reasoned about, like higher primates, unlike ChatGPT. Oh, what? Come on. Ah, there we go. All right, so the error has been picked up. And I've said if we weren't using DCC or using a regular C implementation, Windows, the operating system, would have actually stopped the program and said the same thing in a more less friendly way. Oh, sorry, we're not using Windows. They were on a VLab server. So it would be Linux that would do it. Linux also does that. What's my problem here? You had the answer ages ago, didn't you? Yes, that's awful. There's a lesson here, by the way, which many of you, and I hate to say this, but it's often the female members of the lecture team that will suffer this more. You not only have to know the right answer, but you have to get people to listen to you. People often listen to the loud, wrong person rather than the quiet, correct person. It's a general problem with this world, really. All right. So what do I do about that? My loop's gone too far. How do you make a C loop go backwards? You want me to change? Sorry, can I change line 32? I think I don't think I can do anything at line 32. The trouble is, well, imagine the list. Imagine he's the head of the list. He's middle. She's last in the list. And I'm now null. I wanted to stop when I was pointing at her as last thing in the list. So my loop's gone too far. Is there a C construct that says go back one in the loop? So it's good in arrays, isn't it? You could just subtract one. That's the hacker's thing with arrays. Oh, that's one too big. I'll just subtract one from it rather than fix the earlier code. Off by one, just subtract one. How do you go backwards on a linked list? Think about this. That is a question with, yeah, I know you've got the answers. It's second class all over again. The teacher said 2 + 3 and you know the answer and she's not looking your way. So we'll get to the answer in a second. If I've got a pointer to the third and last node there, can I go backwards up a list? Can I get a pointer back to the second one or a pointer back to the first one? So they're asymmetric data structures. If I chain together all the students in the theatre with pointers, if I've got a pointer to the first person in the list, I'm great, I can get to anyone. If I've got a pointer to the last, I can't come backwards. What would you do about that if you wanted to be able to go backwards? You could have a pointer going forwards and a pointer going backwards and be able to go either way. I don't think we do that in this course. It's a bit scary. What you do in your own free time, of course, is up to you. Oh, this interface is easier than I thought. All right. All right, everyone's dying to tell me to fix line 28. Oop. And my All right. People have been shouting this at me saying, Andrew, do this, do this. But why? That was a rhetorical question. Why? How do we recognize the last node in the list? I give you a pointer to a random node. How do you tell if it's the last node in the list? Its next field contains null. So if you're all linked list nodes, there's only just one of you that has a null pointer. That's the guy right in the back row there. So that while p next not equal to null says while p is not pointing at the last thing in the list. Yep?
Won't this give you an error if your...
Hold that question, hold that question. Oh. Let me compile, let me run. Oh. All right. There we go. Line 28. All right. You remember I gave you some life tips? Arrays, is that index valid? Using a value, has it been assigned one? Is it initialized? Dereferencing a pointer. Is it non-null? Do we know that P is non-null there? Where did P come from? So imagine you're this function. Yeah. So you have to think about what your job is at this function, what your arrangement with is with the people who call you. Imagine this is an internship and you know there's students from other universities there and they're calling your function. You've got to make arrangements with them about what they'll pass to your function. And the question is, have they said P, do you say P is not null? So you might, some functions do say that. They'll have a contract that says, don't call me with a null pointer. Other functions allow it. We can make a more powerful version of this function that can be used to append to an empty list by changing how it works. We're running out of time, so let me modify the function a little to give you the last version, which you can contemplate at your leisure. Oh, we haven't freed the nodes, yes. There's a function, if I change the void, that can be accommodate a null pointer. There is a subtle thing with accommodating a null pointer. is that there's a new head of the list. So this has to give back the head of the list. But we could then use it like this. Oh. If I've got all of that right, oh, no. What am I thinking? Let me see if I can get this working. Ah. There's one slight thing there. Oh, it's a bit scary. I have a printf in my add node to end of list function. There, okay. Thank you. All right. That's a more general part of the function, but it's a lot harder to understand. Fortunately, my time is up, so I'll leave it to Sasha on Monday to start from there and start explaining from there. Thank you for having me for this week and a half. Good luck with the rest of COMP1511.